Okay, let's talk about algebra and what sorts of algebra that we are going to need in order to be successful in solving kinematics problems. I know we've already dealt with some kinematics already, but some algebra issues are popping up. So I'm going to call this a review because, in my opinion, it should be a review. Maybe for you it's the first time you've seen this. I really hope that's not true, but so in its, I guess, simplest form, this is, I guess, the manipulation of equations to solve for unknown variables. Okay. And anyone can do this. So if you think like, hey, there's something wrong with me, I'm not good at math, yada, 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 get over it. That's not true. It's just a matter of putting some time into it, okay? You all learned to speak and walk and, you're all potty trained and so on. You've already done things that are much more difficult than learning algebra. So pat yourself on the back. So it's the manipulation of equations to solve for unknown variables, and let's do some very simple examples. So something that you might see would be something along the lines of this. X minus 4 equals 10. How many people can do that in their head right now without any kind of math manipulation or anything else? Okay, so what is the only number that x could represent? What must x be equal to? 14. Fantastic. We know that 14 minus 4 is 10. Perfect. Okay. That's easy, but we're going to use it to kind of show you one of the most basic techniques in algebra, and that is isolating the unknown variable. Okay, and something like this, it's probably not necessary, but just to remind you of the technique of how we go about doing this, let's go through that. Okay, so isolating for the unknown variable. Isolating for the unknown. And x is often used to represent the unknown, although when you get into physics, they use specific letters to mean specific things. So I mean, for instance, if you're doing electricity, I is often used to represent current in terms of amps, V for voltage, Q for charge, yeah, and so on. Ohms is the omega symbol, yeah, that's right. So you tend to end up using those values to represent unknowns, just because it's part of the language of physics. Okay. Just on a side note, you've already been sort of introduced to some of this in kinematics. So we use v, often with a little arrow, to represent velocity. Okay. T, we use that for time, right, and so on. Okay. We're gonna go generally with this, and then we'll get more specific later. So far, so good. You got it. Okay, so isolating for the unknown. So what we want to do and what we often say in math is we want to get x by itself, okay, or by itself. And if we look and see at what's happening on the left side here, we're subtracting 4 away from here and from the unknown. And in order to get the x all alone by itself, we have to do the opposite function to it. So if we're subtracting 4, yeah, exactly right. So because there's an equal sign, right, in order to keep both sides equal to one another, if we add 4 to the left side, we've got to add 4 to the right. And sometimes it's interesting to think about it like a teeter-totter, right? We know that both sides have to equal 10 in total, right? They have to equal 10 no matter what. How do we know? Because there's an equal sign, okay? So the teeter-totter is perfectly balanced between these two things, and both sides have to always equal 10. So let's say I go on this side and I subtract 4 off, and then I add 4, okay? If I've added 4 to the left, that 4 wasn't there before, then I've got to add 4 to the right, okay? So if I add 4 here in order to keep this balanced, I got to add 4 over on the right. Now what's going to happen here is if I've subtract 4 and then I've added 4, that's the same as doing nothing at all, right? Because negative 4 plus 4 is 0. So what we end up with is the new equation that x must be equal to 10 plus 4, or x equals 14. Okay. So there you go. That's very simply and a simple example of what you're going to do in algebra. You do the opposite operation of what you were working on in order to isolate a variable. So let's try one on our own. How about um, um, uh, okay, so to do in your head, this one's a little harder, but let's take a look here. All right, so the first thing that I see that we'll have to probably deal with is there's a subtract 2 on this side. So I want to get rid of that subtract 2. I'm going to add 2 to this side. So then we get to this point. 14 plus some value equals 10 plus 2, or 14 plus x equals 12. Now, oftentimes, people run into problems when there's something to the left of their unknown. Okay? There's two ways to deal with this. Does the order of numbers matter when you're adding things together? Does it matter if you have 4 plus 2 plus 1, or 1 plus 2 plus 4, or 2 plus 4 plus 1? Do these equal different values? They all equal the same thing, right? So which order you put them in doesn't matter. Subtracting's different. It does matter, okay? But adding is not. It's fine, okay? And I'll give you a little trick about subtracting, by the way, later, so that it doesn't actually matter. But hang on. Okay, so here we are. So could we say then 14 plus x is the same thing as x plus 14? Sure. So then you see, okay, well, if I'm adding 14, my next step is to subtract 14 and get rid of it. Okay, so x must be equal, because that cancels off, to 12 minus 14. Well, 12 minus 12 is 0, and I still have 2 left over, so it's got to be negative 2. And there's your answer. Okay? Are you good with that? All right. Now, I mentioned here that it does matter when you subtract, right? So, like, let's say I go like this. 4 minus 2 minus 1. What does that equal? What does this equal? Okay, so that matters. But is there a way that we can have it equal, or have it be such that the order doesn't matter? Is there a way? Do you think? I won't delve too far into this because it's kind of an aside, but what if you did this? So what if we instead of looking at this as subtracting, we looked at it as adding negative numbers together? Could we also say 4 plus negative 2 plus negative 1? What does that give us? Which equals 1. Okay. What if we changed the order of this? What would happen then? So what if we had negative 1 plus negative 2 plus 4? What happens now? So we found a way that the order of operations doesn't matter. I think this is almost a better way to do it, but it's not really the way it's generally taught. It's kind of confusing maybe sometimes if you don't quite understand it, but anyway, back to the original point. For adding, it doesn't matter. So when you see something like this, it can be, sometimes it causes people problems. Okay, another way to think about it though, if you go back to this scenario here, we can also think about it like this, couldn't we? There's an invisible plus sign in front of there, isn't there? Because it's a positive 14. So if you think about it in that way, then okay, that makes sense. I could just subtract 14 off of that side. Okay, does that make sense? Okay. Want to try another one? Okay, why not? Let's try this. So there's a few different ways to approach something like this. Okay. Um, One way is to just leave it as is and notice, okay, I'm subtracting 11, so I can just add 11. I'm subtracting 12, so I can just add 12, and 15 plus 11 plus 12 should be 38. Okay. Um, but you might also see that if you kind of take this scenario, you can actually look at this problem kind of like this. Negative 12 plus x plus negative 11. Okay? And then you can actually like move this around, right? Because now it doesn't matter as long as you keep the negatives with there. We're adding everything up, so we can just move the numbers around within this formula, right? So I don't know, sometimes I find it easier to get my x all the way to the left and then deal with whatever works out here. So we've got plus negative 12 plus negative 11. So what is negative 12 plus negative 11? Okay. And so then, okay, so now we've got plus negative 23. So we've got to subtract negative 23. So what we'll get is this. We'll get minus negative 23, right? Subtract it off of that side, and we'll get this equals 15 minus negative 23. What happens when we have two negatives beside each other? They turn into a, right, so then we get x equals 15 plus 23, and you get 38. That actually for this problem might not be the best way to do it, but either way is fine, right? It doesn't really matter. You end up at the same point in the end. Algebra allows for some creativity, right, in solving problems. If you want to think about it as creativity, you know, there's some different ways to do things. Okay, I'm going to pause there for a minute, and we're going to do some. Okay, moving right along. We're going to solve problems with more than just adding and subtracting. Let's throw in some multiplying, dividing, maybe even some squares and square rooting, because why not? So let's say you have something that looks like this. 4x plus 18 equals, let me think here, 26. Okay? How do you solve this? You just do it. Well, you can probably see that 18 plus 8 should equal 26. Okay? So you know that this x will probably be equal to 2. It has to be equal to 2, actually. But hang on. But I'm going to show you a little technique that is very useful for solving a problem like this. Okay, I know that that has to be equal to 2. And if you can't do something like that in your head, then you need a technique or an algorithm to be able to solve this. And the key here is you got to go through in reverse order of operations. What is the normal order of operations? Order of operations. What order do you do it in? Okay, oftentimes people say the old bed mass, right? Brackets, exponents, dividing, multiplication, addition, subtraction, and subtraction again. No. So yeah, so let's follow reverse order of operations. Normally, order of operations tells you you've got to multiply first, okay? But in the case of solving algebraic equations, we go in reverse order. So we got to do the addition and subtraction part first. So the first step is going to be to subtract 18 off of the right side. So 4x plus 18 minus 18, that equals 0, equals 26 minus 18. 4x equals 8. Okay, and now, yes, now we want to get x by itself. Well, what we're doing is we're multiplying x by 4. So if we then go ahead and divide x by 4 and do that to both sides because we've got to keep them balanced. Well, 4 divided by 4 is 1x, which is essentially the same as saying x and 2. So 1x is equal to 2, or x equals 2. Okay? Simple. Reverse order of operations is your friend. Okay? What if we have something slightly more difficult? Can you solve something that looks like, let me just think for a minute. Okay, let's see what happens when we throw in some other variables. What if I showed you this? Okay, is that easy? What is x equal to? 5. Mm-hmm. Yeah. So this should be 9. X equals 9. Okay. But how we go about solving this? Well, it's reverse order of operations, right? The first thing you're going to do is you're going to do a subtract 9 because that's reverse order of operations. Then you'll get that x squared is equal to 81. And you might know that 9 squared is equal to 81. So you might be able to solve it right there. Right. So if we're squaring something, the opposite of squaring it is you have to root it, square root it. So x is equal to the square root of 81, and you might know that off the top of your head that that works out to be 9. So x equals 9. Okay? All right. Okay, the last section that we're going to talk about with algebra is manipulating equations without numbers. Okay, so manipulating equations without numbers. Okay, and let's use this equation. This is a physics equation. Q equals mc delta t. Okay, so there it is. Now what if I want to isolate for m, which is mass, c, which is heat capacity, or t, which is temperature? Okay, this is actually the way it's set up is makes it somewhat straightforward. But let's isolate for each of the variables. So let's rewrite this equation such that we can see it in all of its forms. Yes, sir. Mm-hmm. Right. Right. Well, let's make our first goal to isolate for m and see how we go about doing that. Okay, we can do it stepwise or we can do it in one step. Okay, so we'll go stepwise first. We see that m is multiplied by c and then it's multiplied by t. So if we divide by c, that should get rid of the c on that side, right? Because it just replaces it with a 1 on top. And if we divide it by c on that side, we got to divide by c on the other side. So now what we've created is an equation that looks like this. Q over c equals m delta t. We still haven't got m by itself. So now we're going to have to do the next thing, which is divide by t again. So now we've got q over c over delta t equals m. So this is a little bit of an issue, but if you think about it, we're saying divide by c, then divide by t. Or we could say divide by c times t. That works out to be the exact same thing, so you get this. M, since we're just flip-flopping it and rewriting it, m equals q over c delta t. So there's another way to write this formula where we've now isolated for m as the unknown. Okay? And we can go through the same process and we will find that you will get c equals q over m delta t, and that delta t is equal to q c times m. Okay? So this is a skill that I highly recommend when you're given a problem. It makes much more sense to me to rearrange the formula to isolate for the unknown that you don't know before you put any numbers in. I'll give you one more example of that, and I'm going to let you do it. Okay? You ready for this? Let's say that x is equal to 4.2 times 10 to the 11. Y is equal to 157. And z is equal to, I don't know. Who knows? Who knows what these numbers actually really mean? What if I were to say that, I don't know, Okay, if I said this, Q equals, let's write that very well, let's fix that, Q equals X. Maybe this isn't a good example. Hang on. Sorry, that example was going nowhere. I'm gonna fix it up, okay? Let's say that you have this equation right here. Okay, and let's say that y equals 10, m equals 4, x equals 2, and I say solve for b. Now, how I want you to solve this is I want you to take this equation, and I want you to isolate it for b first, before you put any of your numbers into the formula. So get b isolated, okay? I'm going to give you a second to try that. Okay, so if you look, reverse orders of operation here, mx plus b is the same as saying b plus mx. So could we subtract mx right off of here? Absolutely. We can take mx off in one chunk, or if you're, uncomfortable with that, I guess what you could also do is you could subtract off b, then subtract off y, but then you're dealing with a negative b over here, which is kind of inconvenient. So I would say, think of this as b plus mx, it comes to the same thing, and then just subtract the mx as one group off both sides. You should come up with this. B should be equal to y minus mx. By the way, it's sort of important as to which way you write that. If you go mx minus y, that's a problem. That's not how that's written. Okay, y minus mx. So let's see if we can solve. Now we're ready to put numbers in. Y is 10 minus m times x minus 4 times 2. So 10 minus 8, b should be equal to 2. And if you look, and you put stuff into here, okay, so y is 10, and that's 8 plus 2, yeah, that equals 10. So there we go. We solved, we isolated first. A lot of people want to put their numbers in first. I don't know why they get into that habit. To be honest, it makes a lot more sense to me to isolate your number first. And what I was kind of getting at with that first example that I stopped is, what if these numbers are massively huge? And you put them in there, then every time you want to write the formula as you're breaking it apart into its pieces, you have to rewrite a huge number. Like, let's say that instead of 10, this was, like I said, 4.2 times 10 to the 20. And this was like 157.46. And this was like, 18,003.417. Okay? So if those were the numbers, then every time we write this formula, you're going to have to input them. Now, this is a fairly simple one, but if the formula is more complicated, like, let's say you got a formula that looked like this. Which is a physics formula. And now you're asked to isolate for r. And, you're given f, g, m, and m, and they're all numbers that look like this. Well, as you're isolating for r, you're rewriting these numbers numerous times, okay? So that's kind of the main reason. It's much harder to make a mistake just writing one simple letter than it is to write down all the numbers that letter represents, okay? So we'll leave it there.